Hi everyone, it's Judy. Welcome back to the OnTrack podcast. Today we'll be speaking with Yizhak Bot, all the way from Israel. He's the founder and CTO of BQR Reliable Engineering. He'll talk about what derating is and how you can work on the schematic level with their simulation software to absolutely eliminate field failures. I think you'll enjoy this one. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, Yizhak, thank you so much for joining us all the way from Israel. It's a joy to have you, and we're looking forward to learning about what you do and what BQR does.
Thank you very much, and have a great day there.
Thank you. So, Yizhak has been a sponsor at the last two Altium Live events, and last time he even did a talk about a very interesting technology that BQR offers that is particularly applicable to engineers who lay out boards. And it's sort of something related to reliability that we don't always think of. So I think you're going to enjoy this. So Yizhak, why don't you jump in and tell us about your professional background and then tell us a little bit about BQR.
Okay, so first of all, I started many years ago in the Israeli DOD, and I served there about 10 years in reliability engineering of very big systems. And I learned how system works and fail. And we started the company just after that in order to develop software and methods, how to improve the robustness of those systems in the design before the system failed in the field.
So I imagine coming from the DOD, you had some exposure to reliability is always key when it comes to military applications. So I'm sure that sort of tuned you to really thinking about field reliability over time.
Yeah, mostly after we buy the equipment, we need to run them for 20 or 30 years. And this means a very long time. And if you have many failures, that means that you are losing money and they will not operate in the field. So we need to develop the method, how you design better systems in the design phase using the design capture tools.
So since most of our listeners here are designers, engineers, and designers, what are 2 or 3 common field failures that you tend to see?
For example, if you have a CPU and suddenly in the field they just make a reboot. So imagine an aircraft that fly and the aircraft computer suddenly stop working. And this is a very big problem. So, this is one of the problems that we can detect in the design and helping the designer to correct his design so such a failure will not occur in the field.
Okay, what's another one besides a CPU reboot?
You may have safety functions. And everyone knows that the safety function, if you put it together with a non-safety function in one chip or in one board, if the non-safety function fail, it affects the safety function. So you need to separate the design in such a way that failures in the non-safety function will not affect the safety function. An additional failure is if you have a DC to DC converter on a board, you want to test it if the voltage is correct. But today you have many DC to DC converters on the board, and you sample the voltage of all of them to one ADC. And the problem that is those DC to DC are located in different places on the board, and designers sometimes forget to connect them to the same ground. So you have DC to DC, which runs from a different ground, and now you are checking them, and it's become a big issue in the field because you don't know from where the problem comes from.
So from a lot of our designers that are EEs that are laying out their own boards, they're doing the schematic and the layout many times. And so the things that you're talking about, your talk at Altium Live, you talked about derating, which was something I wasn't familiar with. So can you talk a little bit about how it sort of begins in the schematic and what that derating sort of means?
Yeah, derating means, let's say, we can take a simple example of a lift, an elevator that carry 5 people of 100 kilo. So, and if you put a cable that can carry only the 500 kilo, it became a risk because after 10 times the cable will tear. So you need to take a cable of 2,000 kilo. So in 4 times, so you have a safety factor. And the same is in electronic. You cannot take a capacitor of 5 volt and put on it 5 volt. You need to reduce it at least 50% to 2.5 volt. And this is not only capacitors, it's also involved in current and power and junction temperature. So all the designs should be derated and not running at the maximum rating of the component.
So, inside the bare board world, right, we do things, say, inside of a tool like Altium Designer, we run design rule checks, and then once the bare board's made, we do a bed of nails test, and there's testing at assembly. Why do the type of field failures that you're talking about happen when the board's gone through so much testing before it hits the field?
Okay, I need also to tell here a story. So what we did 5 years ago, we cooperate with few telecom companies, and we got thousands of field failures. So we analyzed the field failures with the root cause, and we found it. And then we saw that if we make a small change in the design, and then this failure will not occur in the field. So we built up, we collected about 200 rules. And if you check them now in the design, you are sure that the product will not fail in the field. But what happened that when you do a test and you try to find those errors, you cannot test all the combinations, and some of the errors or some of the failures are glitching to the customer. And then it's a big disaster and can be lost a lot of money. So what we have seen that all our customers that use the technology, the integration test and the qual test and the field test, they don't see any more failures. So they started to do that on all their boards, and they ask also the subcontractors to run those simulations on their boards, so they are sure that what they get is robust.
Okay, so is this sort of the basis of simulation tool that you developed? I believe it's called Fixed Stress.
Fixed Stress, right.
Okay, so tell us a little bit about some of those combinations and things and how you came to choose these or sort of back into these things that you're checking for field reliability.
Okay, first of all the MTBF reliability issues are statistical, and you need a lot of field data to get the numbers. But it's after, and we want to find something which is before. Mm-hmm. So we first of all we developed the simulation tool that calculates the stress level about the components. But since the design was not mature, let's say, and during the design, they have still errors and some shortcuts. And we calculated high current. And then the customer or the designer say, oh, okay, I don't believe, I think your simulation is wrong. So when we do a design review, we found the problems in the design. So then I started to think, okay, what I will do if I want to detect the shortcut before. So then we developed the schematic review. So today we have two main modules, the schematic review, which detect design errors, the 200 rules with additional that the user can add by an editor, and we have the schematic, the stress analysis and derating that checks the level of stress above the component. So those two tools are running in a combination. After that, we can do a thermal analysis and MTBF prediction, which complete the analysis for the designer.
So all of this analysis basically reviews how the components are interacting with one another and the stress that they will be experiencing as a finished product, but at the schematic level. Is that correct?
Yeah. So what we do, the input to our tool is the BOM, the bill of materials, and also the netlist. And also the ICD, it's mean the signals on the connectors and the loads on the connectors, because we need to fully load and power the circuit as in the field. And what happened when we did one by one, it was okay, we found the problems, but later on we did integration between several boards to a system, and then we found that another layer of failures by the connections between the PCBs. And so we went into another level of analysis, multi-board, that you can find system-level problems, and there is no limit of the number of assemblies that you can connect them together to have a system. And customers, they like it.
So you and I were talking about a couple of Boeing crashes, one that was just earlier this week, which is a, tragic failure. Tell us about the impact you're seeing to your customers as they're able to sort of simulate and catch some of these things ahead of time.
So we don't know exactly what happened with those aircrafts, but what I heard was something about the CPU or something like the computer on the board. Some safety elements that the pilot was not trained to use them. So we don't know exactly, but what I see from our customers, from their benefit, in the past they have failures in the field. Right now it's almost zero. So this means that the product can survive a long time, and because the design is good and robust, it's very good for the end customer that the product is robust.
Yeah. And so what kind of applications are you seeing people adopting your tool and how that impacts their particular applications?
Mostly in big systems, harsh environment like aerospace, defense, but also in trains, automotive, ships, telecom, gas and oil, server farms, wind farms, power distribution. Let's say they can have a small mistake in the design, and they can lose millions, tens of millions, and the money which will they save from those failure, they can use our software many years.
Yeah, I can see that. What kind of so you're obviously based in Israel.
Right.
What's your market reach geographically?
Right now we are in the US, in Canada, in Brazil, all over Europe, Germany, France, Italy, UK, Sweden, Netherlands. And also we sold to China, which is interesting, to Singapore, to Japan, and now we are starting to Korea.
Amazing. That's a great reach. So how do you obviously you came to Altium Live and you have a mind to get the word out about this nice solution. How do you get the word out to get that kind of reach, Yizhak?
Okay, this is very interesting also. We are a small company in Israel. We don't have a lot of marketing, but it's done by mouth to mouth. So we have the customers, they tell the other customers, and we have big customers that ask the subcontractor to use our technology. So it come from mouth to mouth. Someone heard that someone saved money using our software, so he came also. And last year we did only in the company as a service 500 boards, which is a lot of boards. It's a lot. It was also a lot of pressure of our people here to provide the results of those boards, and they are coming more and more because they see the benefit what they get.
So, Yizhak, are you providing this as a service, or are you selling the software, or both?
Okay, so at the beginning, we started as a service. And some of the companies, they are used to continue using the service, but they are moving to buy the software. So we teach them how to use it because it's a really new technology, a new concept. And as you said, not many people are thinking about derating and stress. And suddenly they understand that stress is the problem. And most of the field failures comes from the stress. And we are the engineers need to listen to the customer and try to give them a better product. And our tool can help simple in the design, running a simple simulation to detect those errors and provide a report. And it's not only a report, it's a back annotated to the schematic and can show you on the schematic in Altium the component which is a problem and what is the problem, and then you can correct the design.
That's amazing. Well, what I love most about it is really not only you're protecting millions of dollars commercially, but it sounds like you're protecting people's lives in case of military or aerospace and, medical, some of these applications.
Yeah. So we have a lot of experience. We learned about how system fail, how they operate. So we build up those rules in our system that will avoid those problems based on our experience.
Right. Well, that's great. So, Yizhak, I will make sure to share your video from your talk at Altium Live as well as your slide deck. And will you please share with me a link to your website and any other data or case studies or things so our listeners can learn more about you?
Okay, but I will do that later, not now.
Yes, not now. Just before we get this out to our listeners.
Yes.
Well, thank you so much for joining us. It's been a delight to learn more about you and BQR and the reliability that you're offering in the field. I'm sure engineers will be glad to learn more about you. So thank you so much for joining me today.
Thank you very much. Thank you. Bye-bye.
Bye-bye. Again, this has been Judy with the OnTrack podcast. Please remember to like, comment, and subscribe. And until next time, remember to always stay on track.